So in today's session, we will discuss something related to preparation and standardization of X molar sodium thiosulphate solution. So in that, first of all, we'll start with preparation of 0.1 molar sodium thiosulphate 100 ml. So that will be our secondary standard solution. Okay, so as per the rule, we're supposed to deal with its molecular weight. So whatever molecular weight of sodium thiosulphate we have, when you dissolve it in 1000 ml, it will be automatically 1 molar sodium thiosulphate. So can you recall the molecular weight of sodium thiosulphate? Is it right? 248. Yes, anyone from batch A?
Yes, sir.
248 बराबर है? If you calculate Na2H2O3 molecular masses, is it 248 बराबर है कि नहीं? Verify करो.
Sir, no.
કેટલું
Sir,
આવે છે?
158 આવે છે. 158.
158 આવે છે.
158.
So why
Yes,
248 is
150.
mentioned here? What could be the reason?
Sir, because it is pentahydrate.
Yes, it is already mentioned in the slide that it is pentahydrate. So for that, 5 molecules of H2O you're supposed to consider. Generally, it is available in this particular form. 5 H2O water of crystallization is attached with Na2H2O3. That is why it will add 90 point something. So when you add 158 plus 90, it will be 248 gram round about. बराबर है? Hello?
Yes, sir.
Yes, sir.
Okay, so that's why it is 248 gram. So when you dissolve this 248 gram in 1000 ml, it will be 1 molar sodium thiosulphate solution. Now we need to prepare 0.1 molar. So if we convert it for 0.1 molar, it is 24.8, and for 100 ml, it is 2.4 gram of sodium thiosulphate. Fine. So as per આપણે જે અત્યાર સુધી જે discussion કર્યું છે, preparation of X molar solution of any substance, you need to consider its molecular weight. So for sodium thiosulphate, you will have to weigh 2.48 gram, dissolve it in total volume of 100 ml. Your solution will be automatically 0.1 molar. So that is done with preparation of the solution. However, regarding preparation of solution, we required some additional substance. So in place of 2.48 gram, you can weigh 2.5 gram sodium thiosulphate and add along with 0.02 gram of sodium carbonate in carbon dioxide free water. Why it is so? Because it is just to avoid the reaction between sodium thiosulphate and carbon dioxide, whichever present in water. એ બેની વચ્ચે રિએક્શન ના થાય એટલા માટે અહીંયા એક્સ્ટ્રા તમને સોડિયમ કાર્બોનેટ બી એડ કરેલું છે. ઓકે, સો ઇટ સેમ વે જસ્ટ લાઈક NaOH આની બી રિએક્શન થાય છે, and it resulted in some reduction in the strength of sodium thiosulphate solution. That is why carbon dioxide free water along with sodium carbonate is needed for its preparation for secondary standard solution. So that is the first part. Now just look at the procedure first, then we will discuss out its principle. Okay, થોડું ધ્યાનથી જોજો અહીંયા. So regarding the standardization of sodium thiosulphate, આપણે solution બનાવી દીધું છે. So for standardization, we required primary standard. and primary standard for this particular case is potassium bromate. Okay, so initially or likewise you have to prepare primary standard solution of KbRO3. You will dissolve 0.2 gram in sufficient water to produce 250 ml solution. Okay, એટલે 0.2 gram તમારે KbRO3 લઈને પાણીમાં dissolve કરવાનું, so that the final volume must be 250 ml. And from that 250 ml, you will have to measure 50 ml. So what will be the amount of KbRO3 in 50 ml? Yes.
Sir,
It
0.04.
0.04.
0.04. કેવી રીતે શોધ્યું આપણે કે 0.2 ગ્રામ 250 ml માં છે, અથવા in 250 ml it is 0.2 gram. 50 ml માં કેટલા? If you cross multiply it, you will get the answer 0.04 gram. Okay, so indirectly we have taken 0.04 gram KbRO3 as our primary standard in a conical flask. Along with it, we need to add 2 gram Ki powder, means potassium iodide, and we need to provide the acidic medium, that is by adding 3 ml 2 molar HCl solution. So this will be our conical flask. Okay, now here in this case we'll start titrating with our prepared solution. અહીંયા આપણે indicator add કરવાનું છે, but it will be added at the towards the end point. So that એટલે તમને કહું છું, થોડું ધ્યાન રાખજો અહીંયા. So to this resultant mixture will titrate against our secondary standard solution, that is x molar. Okay, here printing mistake છે, it is sodium thiosulphate, not the sulfuric acid. Just made a correction. Okay, let me correct it first. Okay, so to that resultant mixture will titrate against our prepared sodium thiosulphate solution. So when you start titrating, what will happen is, જેવું તમે સ્ટાર્ટ કરશો ટાઇટ્રેશન, એટલે આનો જે બ્રાઉન કલર છે એ ધીરે ધીરે લાઇટ યલો કલરમાં ચેન્જ થશે. So જ્યારે બી લાઇટ યલો કલરમાં ચેન્જ થવાનો સ્ટાર્ટ થાય, after that we have to add our indicator, and indicator in this case is our starch paste. Okay, so when you add starch paste, its color will be like this. Light blue color will be there after adding starch paste, and then again we have to continue our titration with sodium thiosulphate till it shows colorless, or it shows the solution colorless. So this will be our procedure. Again I am repeating. First we'll prepare primary standard solution. For that we'll dissolve 0.2 gram KbRO3 in sufficient water to produce 250 ml. From that 250 ml we'll measure 50 ml and take it in the conical flask. In that we'll add 2 gram potassium iodide. We'll provide the acidic medium by adding 3 ml 2 molar HCl. We'll titrate it with our prepared solution or prepared secondary standard solution. So initially the color will be dark brown. When you titrate it, after certain ml, its color will be light yellow. After that we have to add starch paste. So its color will be light blue, and then again we'll continue with titration so that the color of the solution is colorless. So this is our procedure, and at this point you have to note down your bureau ready. Okay, now look at the principle. This is very important and crucial. So regarding the principle, it depends on the redox titration. So where potassium bromate acts as primary standard. So in place of, or in redox titration, generally reduction and oxidation reactions are going on simultaneously. If we look at the type of redox titration, એમાં એક iodometric titration હોય છે, where iodine gets liberated during chemical reaction. So આ જે particular reaction થઈ રહ્યું છે in this case, it is nothing but an iodometric type of redox titration, where iodine is liberated during in situ chemical reaction. So when we add KbRO3, Ki in acidic medium and we titrate it, so જે addition કરી રહ્યા છે અને જે chemical reaction થઈ રહી છે, that is in situ chemical reaction, and while this reaction is going on, iodine gets liberated, અને આ જે liberated iodine થયું છે, that we are going to titrate with sodium thiosulphate. Okay, so first of all, why this standardization for sodium thiosulphate is needed? Okay, because it is not a primary standard, first and foremost reason કે એની જે પ્યોરિટી છે આપણને ખબર નથી. Second is it is available as pentahydrate form. So એ ક્યારે લોસ કરે એ મોલિક્યુલ, એ જે water of crystallization છે, that we don't know. That's why it is efflorescent in nature, and that is why we can't able to get the exact strength of sodium thiosulphate solution. Further, when we dissolve the sodium thiosulphate solution in ordinary water or tap water, say for example, it has capacity to absorb carbon dioxide and it forms carbonic acid, and this carbonic acid causes slow decomposition of sodium thiosulphate and it forms H2S2O3, which is further readily decomposed to sulfurous acid with the formation of free sulfur. So when we prepare this sodium thiosulphate solution in ordinary water, આટલી બધી reaction થાય, so ultimately it decreases the concentration of sodium thiosulphate, and that is why we have to calculate, we have to estimate its original or actual strength. And the third reason is this solution is decomposed by bacterial growth as well as light. Okay, so these are the reasons which stands or which are responsible for changing or changes in its strength, and that is why we have to estimate the actual strength of sodium thiosulphate, and that is why standardization is needed. As we have mentioned earlier, that for the process of standardization we need acidic condition, slightly acidic condition, because in alkaline solution what happen is જે iodine અને થોડું thiosulphate નું જે reaction થશે એ એક reaction માં થાય, or in other word થોડો portion જે thiosulphate નો છે, it will get oxidized to sulfate. So we won't get actual mole by mole reaction between iodine and sodium thiosulphate. That is why it is necessary to perform this reaction, or this standardization is in slightly acidic condition. So if we look at the reactions, it will be like this. We have taken KbRO3 first, or the solution of KbRO3. In that we have added Ki and HCl. So because of that it will generate Hi, and that Hi will react with KbRO3, and that gives us HiO3 plus KBr. So આ જે HiO3 છે it will further ionizes with the presence of the further mediums in our conical flask. So there is a changes in or the arrangement or rearrangement of oxidation state. So that is, you'll find further distribution of electrons, and because of that there is a formation of three molecules of iodine. And this, from these three molecule, one molecule will react with two molecules of sodium thiosulfate, and it will form Na2S4O6. So these are the three reactions normally takes place when we talk about standardization of sodium thiosulfate. Now, can you tell me what will be the relation? Suppose if you want to find out the factor derivation, જે રીતે આપણે factor derive કરે તો for sodium hydroxide and KHP, or for HCl by considering the sodium carbonate reaction, what you consider, what will be the reaction between, or what is the final relation between KbRO3, our primary standard KbRO3, and Na2S2O3? Based on these three reactions, what is your inference? How many moles of KbRO3 will react with how many moles of sodium thiosulfate, or in vice versa? How many moles of sodium thiosulfate will react with how many moles of KbRO3?
Sir, 1 mole of KbRO3 will react with 2 mole of Na2S2O3.
Okay, 1 mole of KbRO3 will react with 2 mole of Na2S2O3. Okay. Anything else? બીજા કોઈ કઈ input આપવું છે? Just look at these three reactions. Yes, Dharti?
Sir, actually, I'm out of the math, so I'm not able to answer properly.
Okay. બીજું કોઈ ઇનપુટ આપી શકે? મિતાક્ષી આઈ થિંક વાત કરી. બીજું કોણ હતું જે વધારે આન્સર આપતું હતું? Okay, just look at the first reaction. Based on the first reaction, 1 mole of KbRO3 generates 1 mole of HiO3. બરાબર છે મિતાક્ષી?
Yes, sir.
In second reaction, you can see that HiO3 એનું further rearrangement થાય છે. It will further react with the ions of iodine as well as H plus or the protons, and it will rearrange to its molecular form, and it forms 3 molecules of iodine. So what does it mean? Between, if you compare KbRO3 and iodine, what will be the relation? Between KbRO3 and iodine?
Sir, KbRO3 requires 6 iodine. The 3 mole.
Based on the first two reactions, 1 mole of KbRO3 generates 1 mole of HiO3. બરાબર છે?
Yes,
And
sir.
that,
Actually, I was saying, sir, I was only considering as I as ion. So I said 6 ion.
okay, okay. Right? So that HiO3 further their oxidation state rearranges થાય છે, and it forms 3 molecules of iodine. So ultimately we can say that 1 mole of KbRO3 generates or is equivalent to 3 moles of iodine. Okay. Now what about the second one, third one? Now what you say about KBRO3 and Na2S2O3, because આપણે એના પર ફોકસ કરવાનું છે. થર્ડ રિએક્શન પરથી શું ખબર પડે છે આપણને? થર્ડ રિએક્શન છે એના પરથી
1 mole of I2 will require to neutralize 2 moles of sodium thiosulphate.
Exactly. Okay. So based on the third reaction, we can be able to recognize that 1 mole of iodine is enough to neutralize 2 moles of Na2S2O3, like this. Now what will be the final relation between KBRO3 and Na2S2O3, because KBRO3 is our primary standard and Na2S2O3 is secondary standard solution.
Sir, 1 kb, it will require 1 KBRO3 molecule will neutralize 6 Na2S2O3 molecules.
Exactly. Or we can write like this: 6 mole of Na2S2O3 is equivalent to 1 mole of KBRO3. Yes, કોઈને કઈ ડાઉટ છે અહીંયા સુધી કે ડાઉટ છે?
No, sir.
હિતાક્ષી, ધરતી સિવાય બીજા કોઈને અમોલક છે?
No, sir.
Okay, so based on these three reactions, we can be able to find out that 6 mole of Na2S2O3 equivalent to 1 mole of KBRO3. Now, how can we derive factor based on this relation? Now we have got 6 mole of Na2S2O3 is equivalent to 1 mole of KBRO3. Now what will be our further reaction? આપણે આગળ શું કરશું? To generate the factor derivation. Factor derivation યાદ છે ને બધાને?
Yes, sir. Sir, we will convert
Yes, sir.
Na2SO3 in its volumetric terms, like
Yes.
mole into molarity into volume, and
Yes, because it
KBRO3
is
in its molecular.
yes, because whatever secondary standard solution we have, that we have taken in its volumetric form, so we'll convert it into its volume form, and whatever KBRO3 we have is we'll convert it into its gram form. Okay, because આપણે initially 0.04 gram લીધું હતું. Okay, so based on the definition of molarity, we can write like this: can we write like this?
Yes, sir.
It is the 6 times 1 mole હોય તો 1000 ml 1 molar Na2S2O3 solution થાય, but અહીંયા 6 mole છે એટલે 6 times 1000 ml 1 molar Na2S2O3 is equivalent to, regarding the 1 mole of KBRO3 we can convert into its gram form. So જ્યારે moles માંથી gram માં convert કરવામાં આવે ત્યારે what we need consider is its number of mole multiplied with molecular mass. So for KBRO3 the molecular mass is 167.02 gram into its 1 mole, so it will be ultimately 167.02 gram. Now further reaction, further આગળ શું આવશે એના પછી? Yes.
So 1000 ml 1 molar Na2S2O3 will be equal to to 248 grams. So we can write it as 6 into 248 grams of Na2S2O3 will be equal to 167.2 grams of KBr.
See, we have already converted our moles જે છે એને આપણે લેફ્ટ હેન્ડ સાઈડ વાળું જો ટર્મ્સ છે કે જે આપણું સેકન્ડરી સ્ટાન્ડર્ડ સોલ્યુશન છે એને આપણે વોલ્યુમ ફોર્મમાં લઈ લીધું છે. So that is equal to 6 times, if it is 1 mole, suppose 1 mole હોત તો શું હોઈ શકે? 1 mole બનાવવા માટે we can convert it like 1000 ml 1 molar solution એવું લખી શક્યા હોત, but it is 6 moles છે, 6 times 1000 ml 1 molar sodium thiosulphate. Okay, now we'll do like this. We'll convert the left hand side પર 6 times છે અને આપણે સામે લઈ જઈશું. So simple mathematics is that, and based on that for 1 ml it was for 1000 ml, now it is for 1 ml 1 molar sodium thiosulphate is equivalent to 0.02784 gram of KbRO3. આપણે Na2S2O3 સોલ્યુશન કેટલા મોલર બનાવ્યું છે?
0.1 molar.
ઓકે, તો આ ફેક્ટર ચાલશે એના માટે?
No, sir, we have to convert molar into 0.1 molar.
No, sir.
Okay, so one more zero will be added and it will be like this. Each ml 0.1 molar sodium thiosulphate is equivalent to 0.002784 gram of KbRO3. So any questions till this particular case?
No, sir.
Okay, so जो question ना हो तो just tell me how can we find molarity of our prepared Na2S2O3 solution based on this factor? આનાથી further steps શું આવશે? Because our aim is to find out the molarity of Na2S2O3.
Sir, whatever the amount of Na2S2O3 we will get in the titration through the readings, we will put it in this equation. Like for 0.1 molar, if we require 0.00278, then for X molar, how much will be the required?
Okay, so what will be the final equation? If you take, say for example, Y molar, suppose if you represent Y molar molarity of actual or the actual molarity of Na2S2O3 solution છે એની molarity તમે suppose Y molar તમે લાવશો, so Y molar is equal to શું આવશે?
Sir, Y molar will be equal to 0.1 molar into the amount of KHP we will take divided by the 0.0027884.
If we take XML our burette reading of Y molar sodium thiosulphate, આપણું જે solution છે એને આપણે equate કરીએ because we have taken 0.04 gram of KbRO3. આટલું જ લીધું હતું ને KbRO3 ક્લાસની અંદર?
Yes, sir.
Okay,
Yes, sir.
so એ જે આપણને ફેક્ટર મળ્યું છે that was for 0.002784 gram of KbRO3 if it is 0.1 molar and 1 ml. તો એના માટે સાચું છે, બટ આપણું જે છે આપણું સોલ્યુશન કે જેની મોલારિટી ખબર નથી એટલે એ વાય મોલર થયું. એનું સપોઝ આપણે ટાઇટ્રેશન કરીને બ્યુરેટ રીડિંગ શોધ્યું, સે ફોર એક્ઝામ્પલ 30 ml, સે ફોર એક્ઝામ્પલ. સો એક્સની જગ્યાએ વી મે રાઇટ 30 ml and for 0.04 gram of KbRO3 માટે કેટલું? The final equation will be like this: molarity of sodium thiosulphate, which is given by Y Ym, that will be equal to, just we are just cross multiplying the terms. So our aim is to find out XML. આપણે જો XML મળી જાય, then we can easily find out molarity of sodium thiosulfate. Okay, now just tell me your answer by this particular case. If we have prepared 0.01 molar sodium thiosulfate and burette reading is 30 ml, what will be our Y? If we have prepared 0.01 molar sodium thiosulfate solution and burette reading is 30 ml અને same titration કરીએ તો Y is equal to શું આવશે?
Sir, Y is
Zero
equal to
point
1
zero zero
ml
four.
into
Mm, just write down in your chat box so that